class. Try that again. Hi, algebra class. Today we're going to look at the notes for section 1.1, solving simple equations. So I'm going to share my screen here so you can see the notes. And this is the PowerPoint, and it goes along with your student journal. So hopefully you have your student journal with you. And you can open it up. We're going to start on page 4. So the first thing, and here it says from the shelf, but you're at home, hopefully you have your journal at home. Go ahead and open your journal to page 4, and it asks you to write the meaning of each vocabulary term on page 4, and this can be in your own words. So go ahead and pause the video, write down those vocabulary definitions, and then we'll restart the video. All right, so one of the first things you should see on the notes page on page 4 in your journal, it talks about the addition property of equality. And the addition property of equality says you can add the same number to each side of an equation and you still have an equivalent equation, which means you're not changing anything. It's going to stay the same. So when we're doing our notes in the journals, one thing you want to make sure is that if any example is given, so you'll see the notes section, and I usually write example like EX. So go ahead and copy this entire example down. You don't have to write these words down. It might help you, but you're going to write down the equation. So I'm going to do the same thing. I'm going to copy this equation over here, and then I'm going to solve it. So when we talk about solving an equation, it means you're trying to get the variable all by itself on one side of the equal sign. We talk about sides. Sides is the equal sign is what's dividing the equation into its two sides. So we have x minus 3 on the left side and 5 on the right side. And we would like to have x all by itself over here. So it says the addition property of equality, I can add the same quantity to both sides of an equation and it still keeps an equivalent equation. So the quantity I want to add to get x by itself would be a positive 3. And the reason I do that is because if you think of a number line, if you're at negative 3 and you climb up 3, you end up at 0. So it makes these numbers here just go away. Negative 3 plus 3 is 0. I'm going to just be left with my x. On the right side, when I add 3 to 5, I get 8. So the one thing you want to be careful of when you're solving equations is make sure that you're doing the operation to both sides of the equation. That's really important. All right, the subtraction property of equality says you can subtract the same number from both sides and you still produce an equivalent equation. So again, write down example 2 on your paper. So I'm going to write example 2, which is 6 equals y plus 3. So this time, the variable, and remember that's what these letters are called, the variable is on the right side. So I want to keep y all by itself on the right. Well, I have this positive 3 over here. So to undo that adding 3, I'm going to subtract 3 from both sides. So I'm going to switch my color again. All right, so I'm going to subtract 3, and I notice it's 3's in both of these problems. It's not always 3, it's just whatever number is next to the variable. All right, so positive 3 minus 3, that's going to be 0, so we're left with y on the right. And on the left, we have 6 minus 3 is 3. Okay, one thing that's really cool about solving algebraic equations is you can check your work and make sure you're right. So we got 3 for y. So let's plug that in and see if it works. So if I replace this y with 3, is 3 plus 3 equal to 6? Is that a true equation? Yes. So we know we solved it right. So that's one thing nice. You can always check your work in algebra. All right, let's look at the next one. This time we have the multiplication property of equality that says you can multiply the same number on both sides of an equation. Now we've now moved on to, we should be on page 5, multiplication properties in the middle of the page there. All right, so again, copy down example 3, write this. We have this problem here. When you see a fraction like that, that's division right now. So we're going to undo that division with multiplication by using the multiplication property. So I'm going to get my pen, and I'm going to copy that equation over here. So we have this time n, oh, lost my pen. We have n divided by 2 equals 8. Okay, so to undo division, I multiply. Now it's a little different when you're doing multiplication and division, because this time we're not trying to get a 0 like we had our -3 and +3 in that previous example. With multiplication and division, you're trying to get a 1, if that makes sense. We want to be left with just one n. So the opposite of division is multiplication. So the quantity I'm going to multiply both sides by is 2. Since n is being divided by 2, I can undo that by multiplying by 2. And I'm going to multiply by 2 on the right side. All right, now you can think of this as being 2 over 1, right? And these are fractions. 2 times 1 is, and I'll do this off to the side, 2 times n is 2n, over 1 times 2 is 2. 2 divided by 2 is just 1, so I end up with 1n. And in algebra, you won't see those ones in front. They just write it as an n. Okay, so that's what's going on here. I like to just cross off my 2's or whatever my number is so that I can see, oh, I have my n all by itself. As long as this number in the numerator is the same as the one in the denominator, those will cancel like that. So I have n on the left side. On the right side, I have 8 times 2 is 16. Again, you can check. If I plug 16 in here, is 16 divided by 2 equal to 8? Yes. All right, this time we're going to be using the division property of equality. To use the division property, it says you undo whatever multiplication problem you have with division. So I'm going to copy down my problem, and I know this time I have a multiplication problem. And to undo that, I'm going to use division. Okay, a couple things to remember. When you see a number right next to a variable in algebra, that's multiplication. Even though they don't show a little dot or a star or an X, we need to know when the number's right next to it, that means it's being multiplied. So again, to undo multiplication, I'm going to divide. And how I like to write that I'm dividing both sides, I don't use a division, you know, the little line with the 2 dots. I use the like fraction symbol, division. And again, you're trying to get a 1. So whatever number is in front there, if I have a -3, I'm going to divide by -3, because -3 divided by -3 is 1m. And over here, a positive divided by a negative is a negative. 18 divided by a -3 would be a -6. And again, you don't need to write this one down. In algebra, you'll see if you just see an m, that symbolizes 1m. So m is equal to -6 in this case. Again, we can check our work. We can plug it in over here. Is -3 times -6 equal to a positive 18? Is that true? Is a negative times a negative a positive? Yes. Okay, so we know we did it right. All right, on page 6 of your journal, we have some extra practice problems to try. So go ahead and pause the video, try these problems on your own, and then we'll go through them together. So go ahead and pause the video and give them a try. Okay, hopefully you had a chance to try them. This first one, we have addition. So to undo addition, we're going to subtract. So we're going to subtract 4 from both sides. Okay. So that leaves us with W. equals 16 minus 4 is 12. Hopefully you got 12 for number 1. All right, let's look at number 4. This time we have a subtraction sign. To undo subtraction, we use the addition property. So we're going to add 5. Remember, it's always the opposite of what's there when we're doing addition and subtraction. All right. So again, I'm going to cross those off so I know they're taken care of. And I have z is equal to 8 plus 5, which is 13. Again, remember, you can plug things in and check your work. Is 13 minus 5 equal to 8? Yes. All right, let's look at number 7. This time we have number right next to a variable. That's multiplication. To undo multiplication, divide. And this time 4 divided by 4 is 1b. And negative 52 divided by 4, we should get negative 13. All right, one more here. That's kind of written kind of cuckoo. I'll rewrite this. This is q divided by 11. Right. I'm going to just check the journal and make sure that is what it is. Yeah. So we have division. To undo division, we are going to multiply both sides. So I'm going to switch pen colors here so you can see. All right, I'm going to multiply both sides by 11 because I want that q all by itself. Multiply it by 11 on this side. So 11 times 3 is 33. And on the right side, remember, if 1's in the numerator, and even though I don't draw 1, I know that 11's in the numerator. It cancels with that 11 in the denominator, and I'm left with just q. So q is equal to 33. All right, let's see what's on the next slide. All right, for your assignment today, you need to finish the extra practice problems on page 6. You have a few more of them on that page. For those of you who are at home, whenever you complete these, if you could just take a picture of your finished work and submit it to Schoology, and I can check your work that way. All right, good job.